Welcome back everyone, Mr. Allen here. So today we're looking at classifying shapes, more specifically in this case classifying the following triangle. So what we need to recognize first of all are what are the options we have for triangles. And these would be the main ones I think, whether it's an equilateral, isosceles, or scalene triangle. So looking at the lengths of the sides specifically, and whether or not the triangle has a right angle. Certainly there is the option to look at acute angles versus obtuse angles as well, but these would be the main ones we're interested in for this course. So our first option, if I'm looking to determine equilateral, isosceles, or scalene, what I need to know are the various lengths of the three sides. And so what we tend to do is treat this like a Pythagorean theorem. If I sort of think about this line right here, I really have a vertical line that kind of comes up here, a horizontal line that goes across here. And so again, kind of up here and then across here to form a right angle triangle. And if I know this length and this length together, I can work with those together to find the overall length of this side. So in this case, I'm going from negative 19 across to negative 4, so a distance of 15 units, from negative 5 up to positive 10, again, a distance of 15 units, and so c squared equals a squared plus b squared. Use the 15s, take the square root. This length is 21.2 units on the grid. Similarly, if I look at these two lengths, I'm going from negative 4 all the way across to 12, so a distance of 16 across. I'm going from 10 down to 5, a distance of 15. Negative 15 if you're thinking slope, but actually the distance is 10 to here and then 5 more further, so 15. And again, square root of, square this, take the square root, and I get approximately 21.9. The third side should be nice and easy. It's a horizontal distance exclusively. So from negative 19 to positive 12, I have 19 plus 12 more is 31. The math of this, taking the one, subtracting the other, gets me the 31 as well. Just wanted to show sort of the two different options there. We can think of this as a horizontal distance of 12 minus the negative 19. Take away the difference. If it was here to here, say, it would be 12 minus 2. So now 12 minus negative 19 is that 31. But of course, if you can see it, you can also just count. It's 19 to the 0, then 12 more beyond the 0. So these are my three sides. You can see now that I have three different lengths. And so of course, I can classify this as scalene. So the next thing that I'm interested in is determining whether there's a right angle in this triangle. It appears as though there could be one up here, but as we discussed in class, if I try to measure that with a protractor, it's pretty inaccurate. Something like 89 degrees, 91 degrees, even probably 92 or 93 would be close enough that it might be hard for me to do an accurate job with it. So our options, the first one is we'll simply deal with it with slopes and determine whether we have perpendicular lines there and there. So the slope over here from the negative 19.5 to the negative 410 is going to be rise over run. That is to say, given what we already talked about, we went up 15 and to the right 15, and so the slope of that line is positive 1. The second line, this blue one over here, is going from negative 410 to 12, negative 5. Again, rise over run. In this case, we're going down from the 10 to the negative 5, so down 15, and then we're running from the negative 4 to the positive 12, so we're going to the right 16, so negative 15 sixteenths. Not quite negative reciprocals. If this were negative 16 sixteenths, of course, it would actually be negative reciprocals, but you can see that they clearly are not. And so the slopes are not negative reciprocals, so the lines are not perpendicular, and therefore this is not a right angle triangle. We do have a second option here. This one's a little backwards, but if we think about the fact that when we have a right angle triangle, we know we can use the Pythagorean theorem given two sides to calculate the third. We can use that fact and work backwards. Essentially here, knowing that this would be true if we had a right angle triangle, then we're basically just going to test to see whether it is true for the triangle that we're given. So on the left side, so I'm interested to know whether 21.2 squared plus 21.9 squared equals 31 squared. 21.2 squared plus 21.9 squared is the left side of that expression, sorry, the left side of that equation. The right side is 31 squared. And in order to avoid rounding errors, I'm going to jump to the 450 and the 481, which were the actual numbers that were in the question. And so adding those together, I have 931 as being this side squared and added together. This side squared is 961. And again, we can see, seeing as this combination of a squared plus b squared does not equal the 31 squared, we can therefore say that it is not a right angle triangle. So two different ways to go about finding the right angle given the work that we've been doing. And then just quickly a note here in summary, when a geometric figure is drawn on a coordinate grid, the coordinates of the vertices can be used to calculate slopes and lengths of the line segments, as well as coordinates of midpoints if that's appropriate. So we did the slopes, we did the lengths, didn't have any midpoints in that question. And then the keys here are knowing what the different options are for triangles and quadrilaterals in order to then classify them. We have the three that we just mentioned, the right triangle, and kind of an isosceles right triangle, just a combination of the isosceles and the right triangle. For quadrilaterals, we have a few options here, parallelogram, rectangle, and so on. Knowing what each one is, so knowing the definition and being able to establish something based on those definitions, of course, will be fairly important at that point. And let's just see at the bottom here, to solve a problem that involves a geometric figure, it's a good idea to start by drawing the diagram on a coordinate grid. I would suggest that that's not necessary, and certainly as we get numbers that are bigger, we won't be able to do that. If you have coordinates of negative 382 and positive 85 as your xy for one vertex, and 863, 92 as a vertex for another one of your coordinates, as the coordinates for another one of your vertices, then obviously we can't draw that. But doing a sketch and just kind of having things in a general area would be probably a good way to go there. And of course, knowing that parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals of each other become quite important at this point as well.